Hello there. Today we'll be talking about 2.7, and it's about inverse of functions. Okay, let's see what's the idea of an inverse. I'll send you these slides and you can read these notes. What's the idea of an inverse? I'll also send you this slides. So the idea is, when you're having, first you'll have a function, there will be some function, and there will be the inverse of the function. So whatever number was a range here it will be changed to domain, and here the domain will be changed to range. So a function and its inverse are opposite to each other. For example, let's say that you have a function f of x equals to what? X plus 4. So the inverse for this will be x minus 4. So look here, in x plus 4 you have 1, 5. That means instead of x, if you plug in 1, the f of x or the y will be 5. And here you'll have the opposite. If you plug in here 5 minus 4, the y will have 1. So whatever number is a domain here will be changed to a range here, and the vice versa. So this diagram can make for you the idea more clear that they are opposite to each other, or sometimes you can even call them as undo functions. The first one is undoing each, yes, they are undoing each other. Okay, how can I represent an inverse function? This is the way of representing an inverse function. But take care, this does not mean f to the power of -1. This is not an exponent, it's just an inverse. This is not equal to 1 over f inverse is not the same like 1 over f. I'm not talking about an exponent here. Okay. Same thing here. This is what I've been telling you, that the domain will be changed to range and these steps. Okay, I want to go to the examples actually. I want to show you how to find inverse. Example. Let's say we want to find the inverse of f of x equals to 5 minus 3x over 2. Okay, you already know that f of x is talking about y. F of x means, this means y. So now change every y to x, and the x's change them to y. The x's make them y and the y's make them x. So this y will be changed to x. 5 minus 3y over 2. So instead of this y I wrote x, and instead of this x I put a y. Next, you already know that to write any equation, to write any function, it must be in terms of y. That means it must be y equals to blah blah. So to change it to that form, put here over 1, you can cross multiply here. 2x equals to 5 minus 3y multiplied by 1. It doesn't make any change. Bring the 5 back, so it will be 2x minus 5 equals to negative 3y. Divide both sides by negative 3. So the value of y will be, I'm going to just work on this one with the negative 5 over 3 minus 2x. Okay, so it's going to be this way, because minus 5 and minus 3 will be cancelled and give you positive 5, and this 2 over 3 is a negative because of this negative, so it will be, this is my inverse. This is the inverse function of this function. Alright, let's have another example. F of x equals to root of 2x minus 3. You have to do the same thing. Change every x to y and every y to x. This f of x will be changed to y first. So instead of this y, I will write an x here, and under root we'll write 2y minus 3. So here I changed every x to y and every y to x. Next I have to get rid of this root, so I'm going to put a square on both sides. So x squared equals to 2y minus 3. As I told you before, it must be in terms of y, so I'm isolating the y, making the y alone. So you have here x squared plus 3 equals to 2y. Divide both sides by 2, so y equals to x squared plus 3 over 2. So this is the inverse function for this function. Okay. If you want to determine a function and its inverse once they are drawn or once they are sketched, here you have, let's say that this is the function, this is the function. So the inverse is going to be this way, like the one that you're looking at here. So here if you have point BA, it means here it will be AB, domain to range, and the range will be a domain, and there will always be a line between them which is symmetric line for both of them, and this line is y equals to x. So this line that's passing through the origin, or the line y equals to x, will always be a symmetry between a function and its inverse. You can check here more graphs. Okay, so here we can see these graphs, but here you have 2 1, so here it will be 1 2, and same thing here. For example, 0 minus 3, so here you have minus 3 0. Instead you're having this symmetry line between them, which is y equals to x. And same thing you can see here, these two functions are a function and its inverse. They are undoing each other. Alright, now I'll give you a nice idea here. Oops. Yes, by the way, not every function can have an inverse. Some functions you cannot find their inverse. So what's the way to know which function have an inverse and which function does not have an inverse? For example, here horizontal line test for inverse function. That means once you have the function, let's say this is graph 1. On graph 1, make a horizontal line. If this horizontal line is going to touch the graph only once, then this type of graph have an inverse. This type of functions have inverse. They have inverse. And if you are doing a horizontal line test again on this type of graphs, and if this line is going to touch the graph for more than 1 point, that means if the line is going to touch the graph in more than 1 point, this does not have any inverse, so you cannot get an inverse function for this type of graphs. Or you can use this one-to-one function. You can see the table here, and this is the way to test if the function have an inverse or not. Okay, I'll give you 2 questions that I wanted to find the inverse here. So the first function is f of x equals to x squared plus 7. Second one, f of x equals to minus 7 over 2x minus 3. Third equation, f of x equals to cubic root of x minus 1. So if you have any doubt with this type of questions, you can ask me. Bye.